Hi, so today we're going to begin our new topic, how to find the area enclosed by two graph. Let's take a look at question number 1. Let R be the regions in the first quadrant enclosed by the graph of y equal to 2x and y equal to x squared. Find the area of the region R. So if you look at region R, it's an irregular shape. So we cannot use any geometric formula to find it. So we had to use different methods. Today I'm going to show you two different methods. Okay, method number 1. It comes from rectangular approximation. So before I'm going to show you how this comes from rectangular approximation, I'm going to give the formula first. Integral a to b, top function minus bottom function dx. So this is going to be the formula. So now I'm going to derive this formula. Okay, so before I derive it, let's refresh a little bit about the rectangular approximation. So recall when we did the Riemann sum, so we are going to use rectangles approximate the area underneath the curve. So we can use the right sum, or left sum. At the end, when the number rectangle, it tend to infinity, the total or the sum of the area of the rectangle equal to the area underneath the curve. So we state that the summation I equal to 1 to infinity, delta x of I times f x of I, and will equal to the area. So we're going to use the same concept. So let's take a look at here. So we had the R. If I draw rectangles, infinite many rectangles, and at the end I add them together, it will be equal to the area of R. So I'm going to draw one dot one so you can see it. So if this is one other rectangle, so this part over here at the base is delta x, and this is the height, then you will find out that the height is bounded above by y equal to 2x and bounded below by the bottom function y equal to x squared. So we say that the height is a function of x. It's a function of x because it changed as the x change. So you have the y equal to 2x, and then you have the y equal to x squared. So over here, the h is smaller. Here, the h is bigger and bigger and bigger and bigger and bigger, and then smaller and smaller. So the h is a function of x as the x change. So it's bounded above by the top function. So therefore, it's going to be the difference between the top function and the bottom function. So we do top minus bottom because h had to be positive. Only the number on top subtract the number on the bottom, you get a positive difference. So therefore we had to use the top function minus the bottom function. And then we say that the delta x is going to be the base. So therefore we get delta x times h of x equal to the area of each rectangle. The area of each rectangle. So now we're going to make the number of rectangle tend to infinity. So we get I equal to 1 to infinity. So we get delta x of I times h of x of I. As the number of rectangle tend to infinity, then the area of the R will be equal to the sum of this little rectangles area. So at the end, you'll be equal to the integral a to b. And now we are going to say this is delta x times h of x. And we're going to swap the order. So we get integral a to b h of x times dx. And we know that h of x, it comes from top function minus bottom function. So we're going to replace it by top function minus bottom function. And then dx. So we just derived the formula. That is a formula that we talked about in the beginning. That's how we get integral a to b, top function minus bottom function dx. And the a to b is going to be the smallest x value and the biggest x value. Now let's take a look at question number 1 again. So in this case, we have the smallest x value is 0, the biggest x value is 2. If you look at this, is the interval that the r run by from 0 to 2. So top function, so you can see it, y equal 2x is on top, and then y equal x squared is on the bottom. So therefore, you're going to get the 2x minus x squared. The function h is a function of x. So therefore, 2x minus x squared. And then we got 2x minus x squared dx. So we finished writing the integral. So the next step is just go back to what we learned before. We're going to integrate and find the answer. So now we're going to integrate. We simplify. And now we're going to do substitution. 2 squared minus 2 to the third power over 3. And then here you get 0. So you get 4 minus a over 3. And then you get 12 over 3 minus a over 3. And the final answer is 4 over 3. So that means the area of R is 4 over 3 square unit. So we finished using method number 1 to find area of R. Let's take a look at method number 2. Okay, method number 2. So let's see if I draw this line over here. Do you see a big triangle in the area underneath the curve y equal to x squared? So we're going to use what we learned in geometry. You use the area of the big shape, subtract the area of this part, the white part, and then you get the shaded region. The big shape, subtract the area of the white part, and you get the shaded region. So basically you have to find the area of the triangle. Okay, minus area of the white part. That means the area underneath the curve from 0 to 2 and 2 to 4. Then they will give the area of the shaded region R. So now, to find the area of the triangle, we know that we can use half times base times height. It also represents the integral from 0 to 2 underneath the 2x dx. I'm going to use this notation. I want to show you. And this minus integral 0 to 2, because area underneath a curve, a regular curve, you definitely have to use integral. Okay, and then they're going to be area of R. So if you look at this, that's a look like you just the top function minus bottom function, and you separate into 2 integral. So for here, because the area of the triangle is 1/2 times the base, which is 2, and the height is 4, minus. So this part you're going to integrate. And now we just calculate. So you get 4 minus. So you got the 2 to the third power over 3, and then you're going to get 4 minus a over 3. So you get the same answer. So we finished finding the area of the R using the second method. So that is 4 over 3. So this method works when you have a special shape that is landing in quadrant 1 or quadrant 2. The first method I show you all the time, it doesn't matter, it's in quadrant 1, 2, 3, 4, or did want to do quadrant 3 in 1 or quadrant 1 in quadrant 2. Okay. Now let's take a look at question number 2. Question number 2. So we have to find the area of R. It said that let R be the region in the first quadrant bounded by the graph y equal to 2 square root x. The horizontal line y equals 6 and the y-axis. Find the area R. So over here, so we have the area R, and we have the vertical rectangle right here. So the H is bounded by the top function y equals 6 and the bottom function y equal to 2 square root x. Okay, so we say that the H is going to be the difference of the top function and the bottom function. So you can write the integral directly, or you can refresh your memory. Okay, so integral a to b so the top function is y equals 6 and the bottom function is y equal to square root x. So you subtract, so it would be 6 minus 2 square root x. So therefore you're going to get 6 minus 2 square root x. The top is divided by 6, the bottom divided by 2 square root x. And then you are going to find the smallest x value, and the smallest x value is 0. So it's 0. And then you continue, you find the biggest x value you found though is 9. So therefore it's going to be 0 to 9. So we already get this. Next step, we just integrate. So before we integrate, we are going to rewrite it to make it easier to integrate, because I have a square root x. So now we're going to get 6x minus, and then you get 2 times x to the 3 over 2, we get 1, divided by 3 over 2. And then we continue to simplify a little bit. This is going to be square root of x to the third power. Okay. Now we're going to get to substitute 6 times 9 minus, this is 4 over 3, square root of 9 to the third power, and subtract, you found out it's 0, so minus 0. So now we're going to continue. So we're going to have to simplify this. This is going to be 3 to the third power, so it's going to be 27. Simplify. So you got 54 minus 36. And then the final answer is 18. So the area of R is 18 square unit. So next I'm going to show you the method number 2. Okay, method number 2. So you probably already see this. Okay, so let me just sketch it so you can see it better. So here this is 9 to 0. Do you see a big rectangle? And then the y part is going to be the area underneath the y equal to square root x. So we're going to use the area of the rectangle, subtract area. Okay. So we're going to subtract the area under the curve. And then this from 0 to 9, and then equal to the shaded region. So now we are going to say this is going to be 9 and this is 6. So 9 times 6 minus integral 0 to 9 2 square root x dx. So you get 54 minus, so this one you get integral 0 to 9 2 times x to the half dx. So you get 9 and 3, and you finally subtract 0. So you get 54 minus, okay, so you will find out the same as the one before. So you get 4 over 3 times 27. So this is going to be 9, and then you get 54 minus 36 equal 18. So you will find out that it's the same answer. Now somebody will ask, how come in the beginning you did not let us to use the calculator? Okay, so now if you use a calculator, you will get this. You get 17.99999. Okay, you will not get a exact answer. Our calculator have a limit. When you handle square root function or sine cosine, it will not give you the exact answer sometimes. So therefore, I want you to use the regular method with our calculator. So we finished question number 2.